Okay, this is our presentation for our semester project where we made a short sword called the Grade Killer, and this is team 3. So the problem statement of the project was in order to demonstrate knowledge of various manufacturing processes, as well as the connection between designing and manufacture of a product, students were tasked with designing and building a steel short sword. So, a brief introduction, just an overview of a lot of things about the project in general. Students were tasked with making a sword, obviously. The spec stock material was 1/4 inch by 2 inch steel, and the actual stock we ended up getting was a 3/8 inch thick. So that changed a little bit of how we made it. The first thing we started was to do the design work in SolidWorks and get our different dimensions and pick the materials so that we could find out where our center of mass would be, because there was a design spec for the center of mass. A lot of the stuff that was initially designed out in SolidWorks and also our initial process plan did change a lot throughout the project because of various things that came up. Some of those design changes that we had to do for like ease of manufacturing, some of those included the different stock that we got, added a surfacing operation to get down to our 1/4 inch width that we wanted for our blade. The material of the guard and also the process that we used to make it changed. We pretty late in the project utilized the CNC plasma cutter, which made things a lot easier. And that allowed us to use steel for our guard rather than aluminum, which was initially the plan, and also went a little bit thinner, so that didn't really affect our center of mass too much. We had a lot of changes regarding the fixturing of our pommel. The initial fixturing we used didn't really work out, and we also changed the process for that, where we used the lathe and then etched it on a Haas CNC mill. There's also some changes to the way our blade was fixtured when we cut our main edges that we'll show pictures of on, go into a little bit more detail later on. And also the hilt wasn't something that we really nailed down how we were going to do it until a little bit later on because of available materials, and we didn't know whether or not we'd be able to use the wood shop and stuff like that.
Every team had the same project constraints and specifications, which included the blade length being 16 to 20 inches with a tang of 5.5 to 6 inches long. The max blade thickness had to be 0.25 inches, and the blade also had to be double-sided as well. The blade had to be tapered down towards the tip from the base of it being 1.6 inches and then tapering down. The pommel was required to be a spherical shape with 2 flat ends, and one of the flat ends had to be engraved with some type of logo. So our team chose to do the Grand Valley trademark. The sword had to be balanced with the center of mass to like 2 to 5 inches from the guard on the blade. And the blade also had to be made out of steel. The evolution and final design of our blade. So as we had talked about before, the fixturing of the blade was pretty important to get the right surface finish and being able to cut without vibrations affecting the cutter. So in our initial design on the left there, we tried to taper down the angle as well as cut it at the same time to try to reduce the time that it was going to take. We found out that this would actually lead to a lot of vibrations, and those ended up loosening the fixturing of it and resulted in some scratches, which we then changed to our improved approach of using blocks to make sure that the blade was secure, fastened very nicely, reducing all of the vibrations that was going to go into it. And it was angled out so that we could taper it down. And then we angled out the manual mill to be able to cut out the angle for the edges. This actually ended up saving us time because we didn't have to intricately fixture the design of the blade to make sure that it was going to taper and cut at the same time. So that was good. And it also was less strenuous on the tool due to the vibrations and it being clamped down. It was more force. So that was also a good thing about the improved approach. So the material selection, the blade and tang were made out of steel to ensure that the sword was going to be durable. The guard was made out of steel due to the selection of scrap material within the IDC. It was originally going to be aluminum, but the plasma cutter saved us time and used steel because that was the only stock they had here. The hilt was made out of wood to allow for the ease of manufacturing it. And the pommel was made out of aluminum to allow for us to try to design where we wanted the center of mass to be. The required specification of 2 to 5 inches on the blade.
The blade and tang were manufactured using the well saw, manual mill, bandsaw, pneumatic grinder, and drill press. The well saw was used as a means to cut down the steel stock to the desired length. The blade was surfaced and shaped with the manual mill. The rough geometries of the tang and blade point were cut using the bandsaw. The pneumatic grinder was used to smooth and refine the overall geometry of the blade and tang. Finally, the drill press was used to drill the 5/16 inch hole on the blade, which will be used to secure the sword on the provided wood plaque. The guard was produced with the CNC plasma cutter and pneumatic grinder. The G-code of our guard design was generated and loaded on the machine. Once the guard was cut, the pneumatic grinder was used to refine the surface finish of the guard. The hilt was made with the laser engraver and pneumatic grinder. The laser engraver engraved the tang slot on each half of the hilt. Each half was then cut in a rectangular shape with the laser engraver. The pneumatic grinder was utilized to round each half of the hilt, creating a more ergonomic design. The pommel was manufactured with the well saw, manual lathe, and the Haas CNC mill. The well saw was used to cut the stock of the aluminum rod. The rough spherical shape was achieved with the manual lathe. The surface was sanded so that the finished surface was smooth. Finally, the CNC mill was used to engrave the GV logo on the bottom of the pommel. Here is the demo video that we created for our sword. Overall, the production of the sword was completed by the expected date. The team worked well together and handled problems when they arose. If we were able to do this project again, we would use the plasma cutter for the production of the blade and tang in order to save more time. Additionally, the CNC lathe would have been beneficial and more efficient when manufacturing the pommel. Similarly, a wood lathe would have been aided in reducing the production time of the hilt. Here is our final assembled short sword. Thank you for watching.